So looking at example D now, we have f prime of x. So again, we're going to start off with the analysis. Where is it changing signs? Where does it cross the x-axis? And so forth. And then from there, we're going to build up to see what is happening to f of x. So starting off, if you notice, we have that f prime of x is negative less than 0 when we go from negative infinity all the way up to negative 4 right there. And then it's also negative from negative 2, right? Still decreasing. That means that f of x is decreasing from negative 2 to positive 4. So here we're going to say that f of x is negative on the intervals negative infinity to negative 4 and from negative 2 to positive 4. So we can say that f of x is decreasing on negative infinity to negative 4 and negative 2 to positive 4. All right, and then moving on, we're going to say where it's positive, so f prime of x is greater than 0. So in this case, it's going to be on negative 4 to negative 2, right, from right here. It's above the x-axis. And then it's also above the x-axis when we get to negative, so positive 4. And so from 4 to positive infinity. So again, this tells us that f of x is increasing on negative 4 to negative 2, and then at 4 to positive infinity. All right, now let's look at f double prime of x. So what is happening at f double prime of x? Change color. So f double prime of x is positive. So we're going to see where it's positive now. If you notice, it goes all the ways, it's positive here. It's increasing. So now we're analyzing f prime of x. And then it changes at negative 3. So it's positive on negative infinity to negative 3. And then it's decreasing here, stops there, and again starts to increase from positive 1 to positive infinity. So, and from positive 1 to positive infinity. So what this tells us about f of x is that it's concave up, right? It opens up on negative infinity to negative 3 and at 1 comma to positive infinity. And then we're going to look at the negative part about f double prime of x. So f double prime of x is less than 0 on, in this case, it's from negative 3, right? We start off here as negative, from negative 3 to positive 1. And that's it. There's nothing more. So that means that that's the only one part where f of x is concave down. Down on negative 3 to positive 1. All right. And then another thing we can also say, right? So that's just the behavior of f of x. When is it increasing? When is it decreasing? Whether it's concave up or concave down. Another thing we can look at right now too is where does f prime of x equal 0? And that would tells us the critical values, right? So remember, f prime of x is equal to 0 at the critical values, or it's at undefined, right? So at the critical values. And in this case, we have negative 4, we have negative 2, and we have positive 4. So now to determine whether it's a minimum or a maximum, right? These are relative because they're open intervals. So we can say that f of x, let's start off with the minimums. F of x, or the minima, has relative minima at x equals, let's look at the first one. So here it changes from negative to positive. So that means that our graph f of x goes from having a negative slope to a positive slope. So therefore, that's a minimum at -4. And then here it changes from from positive to negative. So at -2, here would be a maximum. And then finally at 4, it changes from negative to positive. So that's a minimum as well. So at x equals -4 and x equals +4. And then our maximum a relative maximum at x equals -2, right? So again, because it changes from positive to negative. And then another thing we can say from this, if you notice, there's two values where f double prime of x is equal to 0, which is right there, and it's right there. So remember, when this happens, that means we're changing concavity, so therefore that could be possible points of inflection, right? So we can say f of x has points of inflection at x equals -3 and x equals 1. All right, so x equals -3 and x equals 1. So now we can finally start to draw the graph for this. It took us a while because, again, this was a more complicated graph than the previous one, right? So we know it has a maximum and a minimum, has two minimums and one maximum. The first one, we're going to start off at -4, so we can say that one's, let's say, about right here. And then the second one, so we go from there. At -2, it has a maximum, so it has to be higher than that value. So let's put it right there. And then at +4, it has another minimum, so we can say it's down here. Okay. So now we're going to draw this graph. So again, f prime of x is negative from negative infinity to -4. So that means it's decreasing, right? It's coming down from the left side. We're going to start off with that. Sorry. So it's coming down from the left side. And then it changes signs, meaning it starts to get positive. So it curves down and then it goes back up. And then again, it changes from positive to negative, meaning it's going to curve back down. And then finally, right, we go negative all the way down to our next value. So it's decreasing all the way down. And then again, it starts to increase. So that could be a possible graph for f of x. Yeah, the points of inflection, -3. So right here, and then at +1 right there. So it changes concavity at those two values as well.